Today we are going to talk about more about data structures, and today we are going to talk about stack and queue. Last session we wrote together the linked list in C using struct from scratch, and we talked about the deconstructor in C++, and also we explained the dynamic allocation in C and C++. In C it was free and malloc, and in C++ it was new and delete. So first of all, let me just review quickly the stack and the queue. You already took the concept from the theory lectures. So I will just briefly review the concept.
Okay.
The stack, the main principle of the stack, that the data you enter to the first data enter to the stack, the last one will exit from the stack. So this we express by first in last out, or FILO, FILO. And we use two methods, push and pop. When I say push, this means I add new data to the stack, and when I say pop, that means I will return the data, and by returning the data I mean I will read and delete. So this like one way operation. You read only one time the data, and it will disappear from the stack. As you can see here from this table, there is a stack. We create a stack with a initial
Yes.
yeah, and we push 5 to it. So the stack content is 5, then we push 3, so it's 5, then 3, because the first one will be at the bottom of the here it's array, like an array. So 5 and 3. Then we check the length of S, the stack, it's 2. Then when we do a pop operation, this means we are going to read an item, and as long as the last entered one was 3, so we will have the return value 3, because it's first in last out. So, and also you can say last in first out. Also you can last in first out. So you can like use another term, last in first out. So now let's see, we do a pop again. We only have 5 now, so it's the return value is 5, and now the stack is empty. We push again 7 and then 9, so it's 7 9. We push 4, it's 7 9 4, and etc. Any question?
No, sir.
Okay. The queue, also briefly, has like the opposite way of working. Queue is like, even the English word queue, you know, when you go to a restaurant or you go to a store that has too much customers, you should stand in a queue, right? Let's say if you want to pay for the cashier, and there are too many people, so you will stand in a queue. And obviously, the first one who is in the queue, he is going to pay first. So it's not accepted if you are waiting for like 10 minutes and someone new come and take your place. No, it should be the first in, first out. So the first one entered the queue, he should be the first one who should exit the queue. So it's called first in first out or FIFO. So it's in contrast of the stack first in last out. Here it's first in first out. And we have two
Okay.
methods or two operations, inq and dq. Actually, it's some I mean different words, but it has the same functionality because in queue you add an item. In stack it was called push. Here we call it in queue. And some references may also, or some you may say search for source code, and you will see that they are using Bob and push also for the queue. So we have here in queue and dq. And again, we have here a table with example. For a queue, we entered 5 and then 3. So the queue will have like here's the first. Here from the left is the first, and from the left from the left is the first, and from the right is the last. I think in this table we did not put the reference did not put the order, but here the first is here. The top will be here. So 5, then 3. Then we DQ. When we made the DQ there in the stack, you remember we took 3, right?
Yes, sir.
Here it's 5. It's in contrast.
Yes.
And again 7, 9, 4, 7, 9, 4. Here when we make DQ, the first element will be returned here by 7. So this is briefly the concept of stacking and queue. I hope they are clear for you. Let's try to implement the stack, but using arrays. I think you already took from the literature or from the theory slides the implementation as a linked list, but let's try to implement this as an array, using an array, not using a linked list. Is your IDE open?
Okay, sir.
Yeah. Or you can just follow the code if you are tired or don't want to write the code, so it's okay. So first of all, we do an include.
Sir,
Yeah.
these codes, it will be on GitHub?
The code I'm going to write, it's the same as the slide.
Okay.
Yeah.
So can I follow the codes for this lesson? Because it will be hard for me to watch the stream and
Yeah.
write the
Yeah.
code.
Sure.
Okay, sir,
So
thank you.
welcome iOS stream. Then let's simplify the things. We are not going to use class. We are going to use a function to create a stack for us. So if we want a function to create a stack, so obviously it will return the address of the stack. So it will return an address. Let's say this stack will handle integer values, so it will be integer start as a pointer. And let's call it as a stack. Here let's think. What do you think we need to create a stack?
And the data?
No, currently we only going to create a stack, only like a stack without data at this point of time.
I don't know, sir.
It should be the size, because as long as it's an array, so you should specify the size. Um, in linked list, you don't have to specify the size, because you can add as much as you can new nodes. But as a
Yes.
list, you need to add size. Uh, okay. So now here, uh, let's say let's say int stack address equal to new integer, and then we specify the size passed by the user here, like this, and then return stack address. Also, we can say return new int. Also the same way. I mean, you can either do this or this, like directly creating, and the return value is going to be returned in the function. Now let's create another function called void push. We are going to push an item to the stack. So what do you think we have here as argument? Ah,
Int data.
yeah, exactly. And also, what other thing?
Uh,
We should also specify the stack we are. I mean, we created a stack, that's correct, but for push, and as long as we are not using a class, so the function push cannot specify which stack to push the data to it. So I will say int stack address. Okay.
okay.
Now let's think if we want to push. Let's say we have like. Okay, so if we have a stack here, you can see me writing, right?
Yes, sir.
Yeah. So here we have a stack. Uh, and here is the base, let's say, or the tail. And here's the top. Currently, commonly we say to the pointer that point to the last entered item to the stack as a top, the top of the stack. So we have also here a top. So here in our code, we don't have top yet, so we need to add a variable and call it top. And this is actually a counter, like a counter for the items inside the stack, which is actually an array. So when we say push stack address, we should say like this, top plus plus equal to data. Okay.
Okay.
This will first of all use the current value of top. Let's initialize the top with 0, initialize it with 0, and then assign to the element of stack, our stack array with the value data, and then increase the top to know currently how much data we have in this stack, and also know where is the last element in our data. What do we
Yes.
still have from to implement a stack? I mean, we still have one method to implement. Can you say which one?
Oh, sir, excuse me.
Sorry.
I didn't understand.
I mean, we still need to implement one method for the stack. Do you remember what is it? What was its name?
Yes, for the remove from stack, right?
Yeah, but what it
Uh,
was called?
pop.
Oh, exactly. So it's pop.
Yes.
And here we just need the stack. We specify the stack we know we want to pop from it the value.
Mm-hmm.
Here just simply we return stack address, and here we say minus, or let's do this. Do you think this is correct?
Uh,
I mean, the
he,
direction of minus minus should be
is it
from left or
should
right.
be have to be it has to be left?
Exactly, yeah. Because when we increase the here, let's say we entered only one element, so top will be equal to 1, but
Mm-hmm.
actually has index of 0. The first element has index of 0. So when you go here and let's say you did this, so this is a bug because it will use the current value of top, which will be 1, and the index 1 will be empty. So it's like this. Um, Now we still have to discuss a case like let's say if top equal to 0, this means the,
The list is empty.
yeah, exactly,
I mean, the stack is empty.
the stack is empty. And actually also when you do a push you should discuss something. Can you figure it out or expect what will should be?
Hmm.
I mean, you cannot push forever. How,
Uh, we have to think the size.
exactly, exactly.
I mean,
So
if the size is enough, so we can't add.
yeah, exactly. So also we are going to store the size as a global value variable. By the way, we call this is a general information. We call the variable inside the function as local or local variables, and outside or the variable that any function can or any source code can access them as global variables. Uh, this is just a small note. Yeah, so here and here we need to update. Let's use another name, stack size. Here we need to update the stack size with the size entered by the user. Here we check if top equal or bigger than stack size. We should also here we need to make return
Yes.
because this one will be not correct. Um, but here it's better to how to say, to define like an error. Uh, um, yeah, for simplicity, we will accept that it will let's say print for us this variable. But usually in like real codes, it's not accepted to do this because you need to check from your code. Let's say you did like int a equal Bob uh, from the stack s from the stack s. You expect it to have a value in a, but actually it was empty. So here it's better to define an error code. We call this in like in practice we call it as an error code. So let's say also for simplicity, let's say you expect to have only positive value, so you can define error code as -1. So whenever you have -1, you know that there is a problem with Bob. Maybe the stack is empty. Okay, so let's return to push. If the top is bigger or equal to stack of the stack size, also you make a cout enough or no free size, no free area, for example, and then you make
Yes.
return. Um, and here in void main you can do sorry, int main. Here you create, first of all you create a stack. So let's call it s equal to stack, and we define the size by, let's say, 10. And here we do push. We say s, let's say we enter 1, then enter 2, then Bob s, just s, and let's do it as a cout. So this is like a complete code for the stack. Is it clear?
Yes, sir, clear.
Yeah, and this one is implemented using an array. To save time, also I have a function, another function to print the stack. I will use an already prepared code to avoid missing time on any typos. So here I simply just cout stack and I iterate. A stack idx is like the top, so you can just think of it like the stack index. So I simply iterate through the all items and print them to know the content of the stack. I have the same functions here. Okay, and I have here a new note that in C++, you can state a default value for your variable, for your function. So if the user forgot or for any reason did not provide the argument, let's say he called stack like this, stack only with one argument, let's say just the length with 5. In this case, the compiler will use, if we have a second argument, let's say init, it will assign to it null. So even as you can see here also, if the user did not enter the length, I will use a default length for my stack. So here, let's say the minimum size of the stack here is 5. So even if the user did not entered anything, just said int star s capital S equal to stack, this will not this will not give an error because it will be used like the length with the default value.
Sir,
Is it clear?
yes, sir.
Yeah.
So if the users enter below the 5, it will be an error?
No. If the user like this example in this comment, if the user did not enter at all the argument, here here is an empty argument, right?
Yes.
There's nothing. So in C you will have an error because you did not define the argument. In C++ you have this option called default value, argument default value. So even if you did not enter the argument, it will be for sure there and have the default value which can be defined by anything by you. You can put 0, you can put 10, you can put 5, 15, anything you want. But
Yes, sir.
usually these are like settings in the code, so you simply define somewhere the minimum stack length or depth or size and assign it to the length argument. The same for the init. Here in my code, I already prepared. I pretended that, let's say, you want to create a stack and make initial value for each. It's an array, so you need to specify an let's say initial value for each item, even the stack is empty. I mean, you initiate when you create an array, let's say int array equal to 10. Usually you create do the initial value with zeros like this, or like do 10 zeros like this. So even in a stack you may also do the same. You want to have initial value for the array members with some number. So I added here an option to do this by passing the array name to the function.
Okay, sir.
Yeah, and here is like look here, if this is another note for the default value for argument. Here I have a default value init equal to null, right?
Yes.
So usually the user will not initiate the array with the values. So let's say the default value is, you will not enter any array to initiate the stack with it. So here I just check if the value of init is not equal to null. That means the user did enter the argument. If it's not null, then do the initialization. Initializations mean just simply scan the items you have in your created stack and assign it with the value of the initialization array. And finally, as we did, return the stack address. Push has the same functionality. We increase the top or stack index and then assign it to item. Pop, we do the same here. We have this bug, should be in reverse like this, and then the print one, and here we create the stack with 100, 200, 300, 400, 500, 600, and then we do a pop 2 times, and let's see what will happen.
It will delete 600 and 500.
Yeah, 600 and 500. Yeah, you are correct. Okay, so okay, here another you remember we check the size when we do push. We check the size. So here when we created the stack we said 5. So this one is okay, this one is okay, this one is okay, and this, but this one is not okay. So at 600 stack overflow. Okay. So it will not enter it. So here it will push the 500. So here it is correct.
And
We
not
don't have the
400.
500 and then 400. So the stack currently has 100, 200, and 300.
Okay.
Okay, clear?
Yes, sir.
Okay. So this was the code for the stack. And actually the code is like the slide here. You can check it. And also I use here I changed the stack index to be top to just to make sure it's the same terms of the theoretical slides. Let's move on to the queue. Oh, okay. Okay. Before we move to the queue, I have here a question. Let's say we have a list of items with the following list equal to, let's do this, is the size 50. We have like 1, 5, 6, 10, 100. Let's say we have this list. Okay, can you think of
Okay.
a way to reverse the order? You can see that the value is increasing in this list from 1
Yes.
to 100. Can you think of a way of reverse the order of this list using stacks?
Uh,
I mean, this is, let's say this is the list we have. Um, the lit the let's say the target we want to reach is something like this. It should be 100, then 10, then 6, then 5, then 1 using stack. And this,
uh,
let's call it list star.
if we can, I don't know if we are able to do this, but if we can change the swap the top sides,
Change what?
maybe there's a top there's a top value on sticks. So if we change this, I mean, if we swap the values between stacks, maybe we can get the reverse of it.
But I need a way using stack only. You are
I
not
don't know,
allowed
sir.
to use for loop. You have a stack. Actually, you should simply think of it as a data you're going to enter to a stack and then do a pop for it inside the same list.
Yes.
So let's imagine if we have a stack. Let me draw it as here. Okay, just increased. Okay, so if we have a stack like this one, and we have this list, we are going to push the values to this stack. So which value you are going to start with? Index 0, right?
Uh, yes. No.
Yeah, I mean for the list, this is the input for the stack. You start with the first one. And as we said, first one will stay in the bottom because the first one entered the last
Yes.
one, first in, last out. So 1,
Yes, sir.
5, 6, 10, and 100. Right?
Yes, sir.
Now do the reverse, which is Bob, and also store in the same list. So when you do Bob, you will have 100, This one will not be exist anymore. Now top
Yes,
pointing to
10.
10. Now this is 10. Now 6, and then 5,
No.
and then 1. So using stack, we could, as you can see here, we could reverse the order as our target list start. You can
Yes,
see
yes, sir.
it's the same.
Yes, sir.
Yeah, so here in this slide, I just wanted to show like a simple question or simple uh, application for a stack. You can simply inverse the order using the stack by pushing, like you can see here, we have 4. And here another thing. It's just a small note also. You remember size of instruction?
Yes.
Yeah, what was its functionality?
Uh, it will declare the size.
Yeah, correct, but in which size? I mean the unit, in which unit?
Uh,
I mean when you do size of A, here we have an array with 7
yes.
elements. Size of here,
Yes.
if you say size of
7.
A, it will 7. It will be 7.
Yes.
No, it's not 7. If you remember, I told you that size of will return the size in bytes. So here, if you have
Yes.
integer, and here an array of integer. So you have here 7 integers, right?
Yes.
So when you say size of A, it will return for you 7 multiplied by the size of each integer in bytes. So integer, it will be 4 bytes, for example. So 7 multiplied by 4, it will be 28. So here in this for loop, we don't want the bytes. So the trick here is to divide the A, which is the total size of A in bytes, with the size of one integer.
Yes.
Did you get it?
Yes.
Yeah, so just remove the size of integer from the size of A. So you will have here only the number of the how many members inside this array, or how many items inside this array.
Okay, sir.
Okay, so here I iterate for all items and push them starting from item 0 or index 0, and then just simply to the same array. Also from index 0, start with index 0, I pop the items to reach to my target, which is inverting the list.
Oh, yes.
Yeah, so is it clear?
Yes, that was clear.
Yeah. Uh, Also, before moving to the from the theory slides from Abdul Hafiz Ojan, he mentioned application for the stack applications. One of them
Uh,
was infix,
yes.
postfix, and prefix notation. I don't know if did he provide any examples.
Uh, it might be.
I mean, from the slides he did not, but from the explanation, did he solve any example or showed you how uh, this works?
Uh, I don't remember exactly, but we it, it has to be.
Yeah. Okay. So anyway, you cannot remember, so I need to explain it again. Uh, it's the postfix and prefix and infix is just a way of representing the, let's say, the operations. I mean, usually they taught us in schools that when you want to add or make addition or add two numbers together, you put the first one, then the sign of addition, and then the second number, right?
Yes.
This one is called infix. This is the normal notation that we already know. But who said that this notation should be the only notation or the only style? Why we don't do that? We state or we write first number, then second number, then the addition sign. Why you just do that like this or in reverse? So it's just like something we agreed on. The like 99% of the humans agreed that this style will be the addition. But actually, there is another styles like this one and this one. This one, you provide the numbers first, and then say the operation here will be addition in
Yes.
reverse, and that's why called post fix. Post mean it will be later. This means
Yes.
post.
Mhm.
Pre will be
Before.
in advance, yeah, before. So prefix, that's why you have the sign first and then the operands. So operator, we call this operator and this operand.
Yes.
So this is the concept of infix, the style we know, and postfix and prefix, the other styles that they are exist, but we usually don't use. But we are going to see these two notations or two styles with a stack. With this example, for example, let's say we have this is the infix style or infix expression we know, and we want to convert it to postfix. Okay,
Okay.
so let's do this together. Now I can do this in one click. Good. Okay. So we have here 2, 3, 11, and 1, 2, 11, and 1. That is 90. Yours multiplied and addition. Okay. So yeah, let's start. We should convert this step by step. Let's duplicate it and start converting. Oh, yeah, like this. Okay, so this one is okay. Now it worked. What you call this cases in Turkish? Toba ya Rabbi, right?
Yes.
Yeah.
Are we going to comment this? Is it prefix, postfix, or just
Yeah, we are going to we're going to make it as postfix. Okay?
okay?
Yeah.
Okay.
So we start first of all. We start with this first part, and actually we start with the. Do you remember from one of the lab sessions I explained to you which operation will start? I mean, when you have
Yes.
multiple operations, you have priority.
Yes.
So we start from the operation or the side of this expression that has the most priority. So first
Yes.
of all, we solve what's inside the arrow. So to
Exactly.
exactly. So, but actually, if we don't have the I mean these arrows,
Then the
multiplication.
multiplication.
Exactly. So we start by 2 plus 3. Now we just remove, as I explained to you, instead of having the sign between the two operands, I just remove it to the postfix. It will be later, right?
Yes.
Okay. And this, we call this as T1. Let's use the red. Okay. This one is this expression. Oh, this expression is T1. We call it T1. So we just replace this by T1. Wait.
Okay.
This one is T1. So now it's T1 multiplied by 11 and addition to 1. So where is the priority now?
The multiplication.
Exactly. So here we duplicate this.
So T2 will be T1 multiplication 11.
Multiplied by
Yeah,
11,
multiplied by 11.
like this. Correct. So
Yes.
yeah. Now let's switch one. This one. Duplicate it. Then go to here. This one is, as you said, T2. And then finally it will be addition with 1.
Yes.
So it will be, let me duplicate this.
T2 1 plus
Exactly.
T3.
And now finally the last step. Now we have this, I mean, we have the T2, but T2 is not defined for us. I mean, we need to convert the whole expression to another expression that use the same numbers, but the order of the signs will be in another order. So we do now the reverse. We say, what is T2? T2 is T1, 11,
11
and
multiplication.
the multiplication. So let's start here, or not start, let's duplicate. So it's T1, 11 star, and we have T1. What's T1?
T1 is 2 3 plus.
T3 and plus, and we still only have now here 1 and plus.
1. Yes.
So this is the expression. We converted the expression from the infix to the postfix, like this.
Yes, sir.
So if we went back to the slides, here we have 2, 3, addition, 11, star, 1, and addition. Did we make any mistake, or it's the same? 2, 3 plus. Yeah, it's
No,
the same.
sir.
Yeah,
Yes,
it's the same. Now we are going to discuss how this will be inside the stack. So again, let me explain here. I will remove all these. Just, I will keep this. Okay. So we have here the expression here after conversion. Let's say we have a stack like this horrible stack. Let's divide it with a certain number of. Okay. So first we will start from left to right. Usually after we convert this, we start from left to right. And actually, when this is another benefit of using the prefix and postfix conversion, that you will you are now free from the interpreting the priority. You already have the expression, and it's
Yes.
already is in the correct order, let's say. And we are
Oh,
going to
yes.
see this because now we'll start from the left, as we said, left to the right. So first of all, we enter 2. Let me do this in another layer. Okay, so we entered 2, then we entered 3, and then we found an operation plus.
Yes.
This,
Plus.
yeah, this defined as you are going to take the last 2 entered values in the stack.
So the third stack will be 5.
No, okay, this is the point that you will make the addition and delete the values. So you will have here
Oh,
only 5
okay.
because
Okay, I understand.
yeah, because you are not going to be interested with 2 and 3 anymore because you have here the summation. And actually, and again, when you do Bob, if you remember, you delete the value. So even if you have here
Yes.
2 and 3, it will be deleted and only store the result. Now you enter another value, which is 11.
Yes. And we will delete 2 of it and will be 55.
Yeah, you will delete the both and just
Yes.
store 55. And lastly, you will have
1.
1 and will be
And
added
then
to the
delete and
55.
56.
Yeah, and this is 56 is uh, the complete answer. Because 2
Yes.
plus 5, 55 plus 1 is 56. So in this case,
Yes.
you are not anymore needed. You don't need to check the priority in this expression, the postfix, and you do as you see. We did all the operations inside the stack. So like this table is exactly what I explained to you. We start from left to right, 2, 3, then addition, 11, multiplication, 1, and addition.
Oh,
Okay?
yes. Yes.
Uh, let's move to the prefix. Another example for prefix. Oh, okay. This is another one, but for a postfix. Let's explain it briefly. We have the expression ready. 5, 3,
Yes.
2, multiplication, addition, 4, minus 5, and addition. We start with 5,
Yes.
and then 3, and then 2. But before I show the stack, I mean when you exercise more, you will find, or you should, from one look, you should say, oh, we have 3 multiplied by 2, then the result will be added to 5, then the result will be we will make subscription what's called subs,
Yes.
subtract
Yes,
for,
subtract.
yeah, subtract for 4 from it, and then make addition of 5. So let's make sure we entered 5, then 3,
Yeah.
then 2, then we have multiplication between 2 and 3, the result is
Yes.
6, and we still have 5. We have addition, so 6 plus 5 is 11, and then minus 4, or we
Well,
entered 4,
yes, will be
minus 4,
7.
7, and then
And then
5,
multiplication, 12.
yeah, then addition, 5 with 7, and it's 12.
Yeah.
Okay?
So,
Yeah.
so why we told the 6 at the fourth, because
Yeah, here, 6 here.
yes,
Yeah, as you
didn't we multiply the 2 and 3?
actually here we already have 5, okay?
Okay.
5 is there. Then we entered 3, then we entered 2, and then we have multiplication. Here,
Yes.
each operation has two operands. Operand is the two numbers you are going to deal with. So you only have two operands. So it will check the stack and take the last or the let's say the last two elements from the top. So
Mm-hmm.
5 it's outside the
So we
operation.
multiplied.
Yeah. So you do multiplication only for 2 and 3.
Okay.
I mean, even when you do the infix, the normal expression, you write 3 multiplied by 2. So you have two
Mm-hmm.
operands, not 3.
Okay, sir.
Yeah,
I get it.
yeah. So is this example clear?
Yes, clear.
Okay. This is the prefix. The prefix. Okay.
Mm-hmm.
How much time we still have? I just okay,
Uh,
like less than 1 hour.
45
Yeah.
minutes. Okay.
So let's do this like using the slide to save time. The prefix, let's do it again step by step. We have this expression, but without numbers. It's just characters A,
Yes.
B, C, D, E. So we have here like from the priority also. You remember we have the multiplication and the division are the highest
Yeah.
priority. So let's
Yes.
start with the AB. Here it's a it's a prefix. So we put the two operands and first the operation
Yes.
or the
Yes.
operator. And now we keep the minus and
Yes. T1.
we call it T1. But now
Mm-hmm.
minus, look, here is another note. Minus is the least priority than the division. So here we will not deal with minus, we'll deal with the division. So
So are we ignore the minus?
no, it will be for another step. We
Okay.
just keep it like this, T1
Mm-hmm.
minus division. Now we just convert for the C and D.
Oh, I get it. I get it. So
Yeah,
because of the priority, we will use the
yeah,
whites.
yeah,
Yes. Okay.
exactly. So it's now division C and D, and we call this as T2. So we have T1 minus T2 plus E.
Yes, sir.
Now
Yes.
all of them has the same priority. We'll start from left to right. T1, T2, and before them we put the minus. We call this T3.
Mm-hmm.
Plus T3E.
Yes.
Okay. Now we
Okay.
will do the last step, which is T3 was T1 minus T1 uh, minus T1
Yes.
T2. So this is okay. So sorry, this positive this plus is from the original or from the let's say last expression we get. So this is uh,
Okay.
the plus, and then T3 is minus T1 T2. T1 was multiplication AB, and T2 is a division CD, and finally we have the E.
Yes.
Okay, is it clear?
Mm-hmm. Yes, sir.
Yeah. So now we go to the stack, but now we are going to enter the value from the right. So we start with the E. So as you can hear, let me just correct this. 1 second. Okay. Okay. So the first row is the input in order, and the second one is the content of the stack. So we have E. We entered E first. The stack has E, then D. So here we have E, then D, then C. We entered C here. So we have E, D, C now. And then we have operation, the operation division. So division takes
Yes.
two operands. So we make the division as a result and store it. C divide by D and then E. Okay?
Okay, sir.
Yeah. And then we entered B, so we have E, and then the result of C divided
C
by D
multiplied
and
D.
B. And then we entered A, which is this one. So we have this content here. And then we have operation multiplication. Operation of multiplications mean two operands. The most two elements in the top is A and B. So we do multiplication by A and B and store the result.
Yes.
And this is the current content. And then we have operation of minus subtractions, subtract, yeah. So we have A multiplied by B, subtract C divided by D from A multiplied by B, and finally we have E, and here we have the final operation. So here is like more clear that if you see here, this last expression is nothing than the first expression here. You see?
Yes.
Yeah, so it's identical, but this way when we have this last expression here, the last line, if you can see my mouse cursor,
Yes.
we don't care about any priority or anything. We just do the steps in this algorithm and store it in the stack and do the simple operations, and finally we will have the result here in the stack.
Okay.
So this is the last slide for the prefix and postfix examples. If you are more interested about more information, there is a nice link on Wikipedia. Let's just see it together. Actually, there are some programming languages that use the stack as a main, let's say, main concept. I mean, it designed around the stack. The whole way this program built is around stack. So as you can see here, like in these expressions, the stack was the main thing that allowed us to calculate the result, right?
Yes.
Yeah, so here the stack is the main thing that used in these languages. So you can see here, like, there are some well-known languages like PostScript and BibTeX. These two languages are used for creating, if you plan to continue master study, for example, you will use for short LaTeX, which is one of the languages to make documentation or make reports or make papers. Fourth, for example, another language which is based on stack. And
Yes.
From here you can see some examples, and from here also they explained the prefix and postfix because they are used in these languages for the operations, mathematical operations. Okay, let's continue. Now we are going to talk about, finally, we reached to the queue, implementation of the queue. Here is just illustration that in queue we have front and rear. It was called top and bottom or top and tail in stack. And this implementation also using array. So here we are just discussing if we want to push a new element to the queue. And again, let's imagine we are standing in a queue for a cashier to pay for our things we are going to buy. So let's say you stand here and someone entered the queue. So the queue will shift to the right and make this new person stand here. And the same for the numbers. We shift all the numbers to the right and put this value there. Or sorry here. Okay. So here we put actually we will do, you can do it in the other way, but here in this example we add the new item here, but preserve the first one will be the first index because here's the index from here. Sorry.
Yes.
So let me repeat it again. We have the index from here, starting from 0
Yes.
and going on. So 0 is the first person standing in the cashier line or the cashier queue. Any new person will come from the last, will stand the last free space. Well, here is 6. Now we want you have now your turn and you go to pay for the cashier. So you moved on. So 10 is no more there. You paid your money and you went for another place. So now the full queue will shift to the left to stand. So 15 will stand in the place of 10. 5 will stand in the place of 15. Is it clear?
Yes, sir.
Yeah, so we did a shift. Each item will be shifted by one place when we do the DQ. And here 66 is the InQ, and when do the DQ, here is the InQ. When do the DQ, we remove the 10 and do the shift for the whole items.
Yes.
So the implementation of the queue is the same of this is also an array. It's very similar to the stack. Just to save time, I will not write it from scratch. Just 1 second. Yeah, this one. But I think here I put it as a class. Yeah, here I will use class because it's more easy to implement. Actually, even for the stack, it was more easy because again, you can see here from the stack, we defined two global variables. It's not good to have this two important information global and available for anything in the neural program. You may have any bug and you change the value of one of them and you ended up with a non-functional program. So it's better to add everything in
Yes.
a stack or in a class.
Oh, yes.
Yeah, so here I returned back to the class implementation. You can remove the class and use the struct if you want to stay with the C and just remove the public, and like this you have C language. Okay?
Okay.
Yeah. So in the queue we have front, rear,
Rear capacity.
and the capacity,
So
and
capacity is the size, right?
yeah,
I mean,
yeah, capacity is the size exactly.
okay.
Yeah. So here when we create a queue, we just pass the the value of the capacity, or what is our needed capacity for this queue. And again, here you can also put a default value. Let's say if the user did not enter the value, you say default one is 10. Okay.
Okay.
So here just update the capacity value with the entered argument, and currently front and rear, I mean it's an empty.
Empty. Yeah.
So front and
Class.
rear are equal. And here just create using dynamic allocation an array of integer with number of capacity you entered.
Okay.
DQ here, sorry, deconstructor here is simply just delete the queue. Delete
okay.
the one you created here. It's not very important. Actually, let's start by inq and then deq. Inq is something similar to what we wrote for the stack, but here we should add the new item at the end of the stack.
Yes.
Again, first of all we check like the stack. If the queue is full, we simply say
Yes. Capacity.
the queue is full, the capacity
Yes.
is full. So and how we can say this, if the rear equal to the capacity, equal or
Yes. The
you
last
can say,
time.
yeah, you can say like this also. It's more safe.
Yes.
Um, okay. Now if everything is okay. Just put it at
Okay.
the end. Anyone new come to the queue will be at the end position. So you can say it like this or just like this and delete this line. It's up to you.
Yes.
DQ here is the, I mean, the NQ is something very similar to the stack, but DQ here is the thing is different from the stack, because if you remember from this paragraph from this slide, we when we remove an item, we should shift all the other items. So
Yes.
here we actually do this. We shift all the items to the left
Yes.
and return
Until I reach the.
until the end, until we reach
Yes.
the rear, which is the last item.
Mm-hmm.
And by doing so, we are DQ. We are doing DQ from the queue. Okay.
Okay, sir.
I think this code here we need to write. Yeah, okay. Here we need this code has a bug because we need to preserve the Q0, which this will be the top item for us. Okay, or
Okay.
the first, let's say first item, or just name it as first, and then we return it here like this. And this one, actually, this example code, maybe they did not have an application, because here in the main function we will not store the value in any place. I mean, when we'll do DQ, we will not use it. But actually, in real case, no one will push a data and will not use it again. So here it should return integer, and we will return the first item in this queue. But it's depends about the application. But in reality, you are not going to push an item if you are not going to use it later. This is display. Display is something similar to the one we created for the stack. This one just check what is your first item. Actually, maybe that's why they did not return the value for DQ, because they have like Q front, which will print for you the item in front which will be in the index 0.
Yes.
And actually, the next slide we will discuss the problem of this implementation. This implementation is ready from the internet, but it has two main issues, and we are going to see how we will going to solve it in another implementation. So here in the main function, we create a queue with 4 items.
Yes.
And we made an any queue with 20, 30, 40, 50.
Mm-hmm.
And then we do display, and finally make a DQ. Like here, you see DQ is not being returning any value, so just
Yes, not returning. So it's queued automatically or just
yeah, it
error
will.
error.
No, it will not make an error. Just it will be deleted. You will lose the data. You are not going
Okay.
to use it. So
So one by one.
yeah. So you have
Okay.
now 20, 30, 40, and 50. Which one will be the first one to DQ?
250.
No, it will be 20, because first in, first out.
Oh, okay. Yes, sorry.
Yeah.
Yes.
So 20, then 30, then 40.
Yes, yes.
Yeah. Okay. And then we will just display and get the queue front, or it's the first element in the queue. So here 20, 30, 40, 50. The queue is full.
It's full.
Now we made the deletion of 2 node. They call it node or can item. So 20 and 30. So we have now only 40 and 50. And front element, or the element in the front, index 0, it is 40.
Yes.
So Actually, this is the code. It's quite simple, but actually we have a problem that as we said, for each time. Let me just enlarge the screen. Each time we are going to dequeue, we are going to shift the whole items, right?
Yes, we had to.
Let's say we have 100 element, or let's say we have 1000 or even
Oh,
1 million. You need to make 1 million operation just for one read operation.
yes,
Yeah, in stack we did not have this problem because each time you read the last one in the array, so you don't have
yes,
a problem. You don't need to do any shift.
yes,
So, but here you are doing the shift each time. So instead of you may think that this operation contain one instruction, but actually in the background it do the shift for the whole array. So this is not good.
yes.
This is called resource wasting of resources. So you are wasting
It's not
power, wasting time.
not efficient.
Yeah, not efficient. So we have two solutions here. Can you suggest one?
If we can do loop
Do
for
what?
the we are we can if we can do loop for the uh, uh, I don't know how to say, I forgot to say we did so what we did at the for a sec I forget the English.
Yeah, yeah, yeah. Take your time. It's okay.
uh, uh, so if we put this process to the loop with
Mhm.
a one I mean if we say equals to zero and then we can do loop and then we can tell the program the targets of I mean how many numbers we will do this loop, maybe we can do it
But
easily.
this loop will do the shift.
Yes, shift, yes.
Yeah, it's the same. I mean, doing the shift one by one. It's this. I mean, the loop in the
Mhm.
programming languages. The loop. Look, when you do, let's say you are going to do here, like here. We are doing shifting, like here, right?
Yes,
Inside a
yes,
loop. So loop is nothing more than um, you are doing like this. Q0 equal to Q1. Then Q1 equal to
yes,
Q2. So and Q1 equal to Q2, and so on. So
yes,
in programming languages, they invented the for to replace these by one instruction, Qi equal to Qi plus 1. So it's, I mean, from the compiler side, it's the same. Okay?
okay,
It's the same time. I mean, even if you do this one by one, even if you have 100 element and you wrote 100 line of code, the
yes,
execution time will be the same.
yes,
Okay? Maybe the code size will be different, but this
mhm,
is like a very small detail, but the execution time will be the same. You are still
yes.
wasting the time. So, do you still have any idea how to solve this?
uh, no, sir.
Yeah. So we have actually the easy one that I expected you to suggest is to use linked list
Oh,
and make the you remember in the linked list we have the head, right?
yes, heads, yes.
Yeah. So this is nothing more than a list with a
Yes,
head.
front equals heads.
Yeah, exactly. And the
Yes,
rear will be the
it
last
will
node.
be the last note.
Yeah.
Yes.
So each time, like now, you can, if you can imagine,
Hmm.
this the green boxes and the red boxes is nothing more than a node. So each
Hmm.
time you just link the last node with a new node, and this one is the rear, and head is still the head. Now
Yes.
when you want to delete the head, you just simply remove the next pointer. Sorry, you remove the item, delete the node,
Yes.
and
And the head will be next node.
head of the next node of the head.
Yes.
I mean, the old head. Let's say the old head.
Yes.
The next pointer of the old head is the new head.
Yes. Yes.
Yeah. So this is the simplest solution. And that's why the linked list is useful to be used here. So anytime you do the deletion, instead of having like 100 or 1000 or equal to the number of the items inside the queue as shift operation, you just have two operations, which deleting the node and updating the value of the header. You can see the improvement.
Yes.
Yeah. The second solution without the first solution means that you are going to change the code from scratch. I mean, instead of using array, you are using linked list. So you are using different data structure. You have two different
Yes.
implementation. The one based on array, which we discussed, and
And
another
linked
one
list.
linked list. Correct. The second solution to improve this is to deal with the front and rear pointer. So instead of doing shift, why we just make the front point to the next item? So front here as a pointer, we just move front. We should move all items while we can just move the value of front and say the value of front will change to 15. So if look, here is this line in green is the value of the memory address. So when you want to dequeue 10, the front value, instead of being 5000, we update it to be 5004.
Yes.
Is it clear?
Yes.
Yeah, so in this case we are moving front one by one instead. So we are moving just one variable instead of moving whole items to the left. Okay.
Okay, sir.
So this is two proposed solution, and again, move the front pointer instead of moving the whole queue. So we have one operation, or using linked list, as again we delete the head and update the head value with the next pointer of the old head. Now is the fun part that you need to implement this
Yes.
in C++, but you can
Okay.
start from the code just to keep you like with a basic code. I just
Okay.
wrote it very simplistic code for you,
Okay.
and asking you to implement the queue using linked list. So you have now the class of node as we discussed before, node with the constructor, and we have class linked list. Again, we have insert node, and you need to add also delete node. You should add full code for linked list, and the queue which contain a linked list, one linked list, and have a
Okay.
queue in queue, and inside the queue in queue, as you can see here, you have insert node. Actually, this insert node you can just use you have the complete code, by the way, from the GitHub. You remember?
Yes, yes, I checked yesterday.
Yeah, so you have the complete code. So it's like Lego. Just go from the resources and just complete the code. The idea is
Okay.
clear, right?
Yes, yes.
Yeah.
I will check it.
Okay. Exercise 2. Actually, this one is implementation for the other. I mean, we have two solutions, right? This one and this one. Linked list is clear. The second one
Yes.
is moving the the pointer.
Okay.
Okay, so now actually in this exercise you have two options. You can select any one of them. Either you implement this, what I told you about, having a pointer pointing to the first item and moving the pointer each time you do dequeue, So you do
Okay.
just simple modifications to the sorry to this code. Here you need here you have front and rear are just real values. If you
Yes.
want to add the pointer, you just need to remove the values, making it as a pointer, and do
Mm-hmm.
the what is needed to make it pointing to the first item. And this
Okay.
is mostly like 2 or 3 lines. What I propose, which is better for you, is to implement something called circular buffer. And actually, it's the same thing. If you did this or this, you will learn the same thing, but
Okay.
like in different flavors, in different way. What I prefer, what I suggest to you is to actually implement circular buffer. But if you don't have time or you could not did this, just do the modification to the main code and implement the pointer. Okay, is this
Okay.
clear?
Yes.
Yeah. The circular buffer, I will explain the the concept for you. And actually, sorry, before explaining the concept for you, if you did this, you will have extra marks because this include that next session you will present for me the concept of the circular buffer and the
Mhm.
operations that you usually do inside it.
Okay.
Okay?
Okay.
And
Mm-hmm.
the circular buffer is an important thing that you may face in your real life while coding. So it's an important thing to know the circular buffer.
Okay.
And
I will
actually,
check it out.
yeah, so the circular buffer, if you searched for it, it's like a special kind of queue.
Okay.
One
I.
types of the queue. So I will just give you just 2 lines about circular buffer, and if you choose to do this and get extra marks, you can do this. Explain next session. The circular buffer is like a queue. You enter the element again in in order. First
Mm-hmm.
in, first out. Also the same. First in, first out. But you have 2 pointers,
Yes.
head and tail.
Yes.
Each time you enter new item, the tail will be increased, and you enter it in the free space. Here, the one in gray is the free space,
Yes.
and
So
the
they
green
will. So they will meet in the middle.
exactly. When they
Mm-hmm.
meet in the middle, this
The
means two
storage is
things.
done. Full.
Yeah,
Yeah.
yeah, full
Mm-hmm.
or empty. You have
Yeah.
two cases,
Mm-hmm.
full or
Mm-hmm.
empty. So actually, all the operations is about the place of head and tail. So if head is before tail, that means you have data. If head is the same position of tail, that means it's empty
No,
or full.
same. Yes.
This need more discussion.
Mhm.
So if you choose to do this, you can present for us next session, and I encourage you to do this.
Okay, I will check it out, sir.
So we still have like 20, 10 minutes, 20 minutes, like 20 minutes or more. Wait, 20? Yeah, we still have more, like half an hour. If you want, let's have a break by 2 or 3 minutes,
Okay, sir.
okay, and continue. Yeah. So still have like very few slides. These are like some concepts I intended to give you in while reviewing C++, but I did not have time. So let me quickly make an overview
Okay.
for you. And again, it's up to you to use C or C++. But if you are going to use C++, it's very important to know them. The
Mhm.
concept called overloading. If you remember, I told you that one feature of C++ that was in session 2, um, you can do an overloading not only for the function but even for the operator. So if you have like sign of plus, minus, multiplication, even the access or what's called subscript. When you access to an array, you define the index with the subscript. So even this operator can be defined, redefined, or this called in the terms of programming overloaded. So overloading done with the classes. When you define a new class, you define the operator. So if we have, let's say, we have our own implementation for an array with 10 items, okay, we call it array 10. We need to access to the items. Usually we define a function. We say like read, and in the return we return the item inside this array. But if we want to make it more easy to the user, because finally you are a programmer, so let's say you are making a library and someone else you're going to use it, so it's not very nice to access using each time read method. Maybe it's more convenient or more easy to access like a simple array using the usual subscript, this one. So we define our own operator, because if you did not overload the subscript with this way, you will have a compilation error. I mean, if you created an array 10 like this array and did like this cout array ARR 9, you will have compilation error, because this operation is defined only for the array, for the simple array. Or if you have another class which define this operator. But for this class, if you did not overload the subscript, you will have an error. So what we simply do, we just say operator. You only add the name of operator and the operator sign. So here, yeah, and here is like any normal function. You have the return type. Instead of the name, you say operator and the sign of the operator, and then the argument. Okay.
Okay.
So when you like deal with an ordinary array, again you pass only one argument inside the arrow, inside the bracelets. Brackets. Inside the brackets, you only pass one value, which is the index of the item inside this array, right?
Yes.
Yeah. So here the argument is 1, which is the index. So int idx, and simply inside the definition of the body of this method, you just say return for the internal array, because here we have a private underscore array with size 10. That's why called array 10, with the idx, which is passed by the operator. Is it clear?
Yes, sir.
Yeah. So you can see that this by doing this, this required from us one line of code, let's say, but the impact is very nice, because each time you can just simply say cout ARR 9 instead of saying ARR.read and then 9. This is very simple example. Maybe in other example it will be more complicated, but this way we can have our own operators. The same thing can be implied for the point. Actually, I intended to write these together, but we don't have too much time. So I will present to you as a code. You remember from also past session, we defined a class for a point. So if we let me delete all these. And also this. Okay, if we have 2 points, like this, or like 2 and 3, and we have class point
Yes.
already defined. Let's say it's already defined, the code is presented here,
Mm-hmm.
and we created, and we have this point p1, we created called point p1, and said, if you remember the implementation, we have constructor, you specify the x-axis and y-axis, or uh,
Yes.
coordinate and y
Mhm.
coordinate. uh, Now if we have another point, let's say point p2, 1 1. Now if we put in on our program b1, if we want to make addition before knowing the um, operator overloading, we may define here a method and name it as like int add, right?
Yes.
And here pass p1 and p2, pointer point p1 and point p2, and make the addition. Here the code, here the argument, list of argument, and here is the body, right?
Yes, sir.
But instead of doing this, this is not very friendly. We say the better way to do is just saying p1 plus p2, and say this one is, for example, equal to point
Three.
p3, exactly. So this is more nice than having, sorry for the bad, uh,
Oh, no,
yeah,
no, sir.
bad drawing. Yeah, so this is more nice than this, than having add, because in add you need to remember the list of arguments. You may do like an error or a typo, do like passing the wrong argument, swapping the order. You have many different possibilities of doing an error. But when you do b1 simply plus b2, it's just the ordinary expression that we usually do. But without doing overloading, this one will be an error from the compiler. You will have here an error. So you need to define the operator overloading, which is something like this. You simply say, again, the return type, then operator, the sign of the operator, which is addition or plus. Then you pass the p1, then p2, and then return temp. Temp is the point, the new point that you are going to return, which consists of p1x plus p2x and p1y plus p2y, and return the addition, the new point, the temp point. So
Okay.
here we have point 1, point 2, and we make the addition, and
Mm-hmm.
then make the. It's very clean way to write your code. Um, this is operator overloading for linked list. Yeah, this is another example. In linked list, do you remember we have like if we want to access, if you went also back to the complete code of linked list, if you want to access, you specify the index and make
Yes.
a method called like read item. And again, in list also it's more easy, it's more friendly to access using the subscript operator. And you only have, I mean, the same method that you already implemented with like a dedicated method called read item. Just copy the same code and put it here. And now when you want to access a list, you just access it as an array. I mean, the same way of an array. So this is more nice. If you went back to the session, you will have the same code here. But instead of having here a dedicated method, just operator subscript and the single argument, which is the index you want to access in the list, and that's it. Is it clear?
Yes, sir.
Yeah. So this is another exercise, and actually I intended to make next session a quiz, but instead of this, I like to be more practical.
Mm-hmm.
I know that quizzes is not friendly with students, so I prefer to work with code better than having quiz. That's why in this assignment you have three exercises, and somehow they are long.
Mm-hmm.
But this is simple. Again, you have the complete code. I just asking you to implement the operator overloading for addition, but this time not for the point class, this time for the linked list. So you have two linked
Mm-hmm.
list, and just I want,
Addition.
yeah, to make addition. So I have linked list 1, linked list 2. I want
Mm-hmm.
you to make a linked list 3 and assign the value of linked list 1 plus linked list 2 to be assigned to linked list 3. Okay?
Okay, sir.
And for simplicity, just to make it more simple, expect that the size or the number of the nodes is the same. So
Mm.
no need to discuss special case like this one. The list one has more nodes than this two. They have the
Okay.
exact number of nodes.
Okay.
And actually, if you are a good programmer, I expect from you to discuss this as an error. If list one has a less number of nodes than list one, then throw an error. Say the length of the two lists are not equal, addition
Mm-hmm.
is not possible, for example.
Okay.
Okay, last this is the last two slides, very fast. I just want, this is optional, it's not requested from you. I just want to say that all things that we are studying, it's already implemented in C++, and the STD or the STL, they call it STL, the standard library. Again,
Yes.
if you remember, we have STD, we use it, right, for C out, or
Mm-hmm.
when
Yes.
you use it here using namespace STD. And
Yes.
I told you that this is like an internal place for C++ that has its own classes, own definitions, own operations. So inside it, you will have also an implementation for the queue and the stack and the linked list. I'm just here presenting the linked list.
Yes.
So here you have a class called or a library called forward list,
Mm-hmm.
and inside forward list or from this library, you can create a list in this way. You say forward underscore list. This is the name of the data type, and
Yes.
you specify the value, the node types. You remember the assignment that you are going to solve. You may have different
Yes.
data types,
Yes.
or the simple way, or the usual way to have one data type for all nodes. So
Mm-hmm.
you specify the node type in integer and then the name of the list. And then
Mm-hmm.
here you have like a assign method if you want to push many nodes. So you
Mm-hmm.
have node with value 1, and then node for value 2, and then 3, and then 4. Here you have remove, like delete a node with index 2, for example. And this way you can print the list. Um, this way of for usually is like have integer I equal to 0, then semicolon, int I less than, let's say, 10, then semicolon I plus plus, right? This is the usual for. But in C++,
Okay.
we have more types of for. This is called range-based for loop. Again, is not requested from you, but it's not nice to know. When you need to iterate using a list, you can specify here the value you want to return while iteration, and this is the range. If you went back, it's very nice to use this website. It's very well known for C++, called C++ reference. So anytime you have any difficulties, you simply go and check. So here they explain the statement for you, the syntax for you. You have here the range expression and range declaration, and you may have like also explanation or examples. In our case here, you have the D, which will be the return value of the iteration, or the value that when you do the iteration, you will have each iteration a return value, and this value will be D. So D is the node. So you have the list of node. D is the node of each iteration. So instead of having your own for loop and defining int equal to 0 until I less than the size of the node, and access the node each node using a method or the operator, you just do this for and see out D. That's how you print it. Actually, I intended to explain to you what are these signs, that integer is inside them. This is the first time to see this, but let me explain it in another time when we have time, free time, because this is optional. Actually, if you want to search for this, it's called template. Template in C++, I just will give you an idea. Template in C++, when you let's say, let's move back to the point class. When you have point class, we have like here double x and double y, right?
Yes.
There is a way in C++. Instead, let's say if you want the same class of point, but instead of having double, you want float. What you should do, you should implement another class and say float x, float y, right?
Yes.
Instead of do this duplication, this is nothing more than duplication. You need to make the exact copy of class point with double. Instead of double, you put float. There is a way called template. You know the name of template or the word template in English? It's well known.
Yes.
Template means anything you are going to reuse in your way, in your
Yes.
context. Like
Yes.
template in template presentation in PowerPoint or whatever. You are going to
Simple,
use
yes.
where?
Oh, I told template samples of the
Yeah, it's like
what we do.
samples. Yeah, it's like
Yes.
samples. They called also template. So it means that you have a frame, but you can put your own picture inside. You have like a design, but you specify what will be go inside this. You have this the basic shape of this design is the same, but you may have simple differences. So here in class, instead of again copy the code again and do the same code but with different data type, you do what's called template. So in template, you say this template will have variable data type. It could be double x, it could be float, it could be anything. So that you add to the class the keyword template, and in a certain way, and this provides you the mechanism to specify for x and y any data type you want. Actually, template need more and more explanation, but this is the concept of template. So anytime you hear of template or want to read about template, at least you have the basic concept of template. And when you want to create, now we already have a template. I'm just explaining why we have this two new signs. Now you already have a template. Let's say forward underscore list is a template. Okay.
Okay.
Despite of or without looking for the details of how we defined the template forward list. Now this is the important thing to know. When we want to create an object from a class, usually we just say, for example, for point, we say point p1. This is an object. But when we have a class with a template, you should specify now for the compiler the differences you have in your objects. So list now in our example, we have a list with integers. So we should tell the compiler that for this template, which is by the end is a class, this class use the version of it that accept to have nodes with integer. Is this clear?
Yes.
Honestly, not for about to save time.
Oh no.
Yeah. So even for the point example, just very quickly, let's say we have now, without going to details and implementing the template, let's say our point class is a template class. So when we want to create an object, instead of having point p1, if we want to have a template, we just say int. In this case, the p1 can have coordinate with integer. If we put float, you can accept float in your template and specify that p1 has x and y in float data type. Is it clear?
Yes. Yes.
Okay. Finally, this is, you can read it at home. It's the same way of, again, we have the STL in C++. And again, they have stack and they have queue. What is it? Queue. They have stack and they have queue. These are internally implemented in C++. You can use it as the usual. You have push and pop. It's the same, but the implementation is not your side. It's from the C++ side. Okay.
Okay.
So this is for today. Please try to submit the assignment of last week this weekend.
Okay. Yes. Yes. I.
Yeah, and try to solve the question. And again, I did. You will find it long, but this is instead of having a quiz. So please try to make your best to implement the questions.
Yes.
So we can discuss the next session, and please make your effort or try your best to prepare also the circular buffer, even in concept in simple implementation. Even if you can take a ready-made code, I will it will be okay. Just understand the code and explain it to us.
Okay, sir.
Okay.
Mm-hmm.
Okay, so have a nice weekend and see you next time.